Hey there, everyone. In today's teaching lesson, I want to take a look at network analysis of stocks and graph analysis of stocks. And we're going to use Python as always. I always use Jupyter Notebooks for all of these teaching sessions I do, and I will share the code with everybody. So you don't have to worry about taking notes or trying to memorize all of this stuff. I will post all the source code when I post the video, so you can download that as an HTML file, and you can open that and copy and paste it into your own Jupyter notebook, and you can see exactly what I'm seeing. You can do the same analysis I'm doing, and of course you can change the inputs and the features and the type of analysis, right, to suit your needs. So I try to make all these things pretty generic, but try to illustrate the point that I'm trying to focus on here, and trying to make this generic enough so you can plug in your own specific requirements, right, and solve your own specific problems, because your problem might not be exactly the same as my problem. It probably won't be, but it'll probably be somewhat similar, right? So I try to make this pretty flexible so you can copy paste, run this as needed, and then input your own specific parameters or requirements or constraints, right, and solve your own specific problem. So network analysis of stocks emphasizes a relationship and a connection between stocks using graph theory to analyze how they're linked together, right, based on shared characteristics like return and volatility. These are two things that we're going to focus on today: returns and volatilities of stocks. But it could be anything. It could be any kind of fundamental feature. It could be return on equity, return on assets, price to earnings divided by growth peg ratios, right? Price to cash flow, like any kind of fundamental feature. I have another video that explains everything about stock fundamentals and how to do analysis of different stocks using fundamental analysis. I have a video on technical analysis. So there's a bunch of ways to look at this. Today we're going to focus on just returns and volatilities, but of course you can do this any number of different ways, right? So we're going to look at the relationships between different stocks, and again focus on returns and volatility. We're going to look at how stocks are interconnected, and how they react either similarly or dissimilarly, right? And the application for this is network analysis. Usually involves investing systemic risk. So systemic risk is market risk that will affect the entire stock market, right? Like specific risks are specific to one stock. Apple, Microsoft, Cisco, Walmart, Ford, right? Whatever specific stock that is specific to the individual company. Systemic risk is for the entire market, right? Like we saw a big crash in 2008, 2009, the global financial crisis. There was a systemic risk when the dot-com sector blew up in early 2000. We saw systemic risk during COVID, right? So these are things that affect the entire market, and that is easily detectable using network analysis. And we can visualize the results. We're going to see this in just a minute, how this works, and the nature of the connections between these different stocks. Graph analysis is a little bit more theoretical. It's very focused on mathematical frameworks, and the applications are broad to graph theory, structures, properties, and mathematical algorithms associated with these graphs. And the data representation involves nodes and edges, and the analysis is highly focused on mathematics and the connectivity between different coefficients. Remember, we're focusing just on returns and volatility, but again, it could be anything you want. So I'm going to import some data from the web right here. This comes from, where is it? Pandas data reader. Okay, so this is the main library that imports all the data. I'm going to import data from this list of stocks. We can tell it's a list because we have the square brackets here. This could be a dictionary. This could be a data frame. Doesn't really matter. I think a list is very easy to work with. It's very flexible. It's comma delimited here. So we're going to feed that into this Pandas data reader and import the data from the web. Okay, and we are going to go back 6 months in time. Okay, so I'm getting datetime now. This function gets datetime now, and I'm subtracting 6 months back. So we're going back in time for 6 months, and we're going to pull in the ticker, the date, and the adjusted close price, right? So this is not real time. This is closing market price for the last 6 months. We can see I just ran the script in the cell, and this is 10/3/2024. So that is actually looking 1 day ahead. I probably have to subtract 1 day. Doesn't really matter for our purposes here. And we're going back in time 6 months. So it goes back to April 2nd, 2024, and we import all the data, and this is what it looks like. Okay, so we see the adjusted close price. We did a pivot, data frame pivot, to get it into this shape, right? So we see Apple, Amgen, Amazon, AXP, BA, I believe that's Boeing, Caterpillar, CRM, Cisco, Disney, and so on and so forth, right? So this is pivoted, and if we go ahead and run this cell, we will see all of the returns, right? This is very easy to calculate. Returns is table.%change.mean times 252. There's 252 trading days in 1 year. And to get the volatility, we're doing table change dot standard deviation, right? So standard deviation and volatility are the same thing here. And we're looking at the square root of 252, again, the number of trading days in the year. And we see this in alphabetical order. So Apple, Amgen, Amazon, down through Verizon and Walmart, right? And we can do the same thing. If I hit Control Enter, this will refresh this data frame. And we are looking now at the sorted data frame in descending order by returns. So here we have Triple M, Walmart, and this is annualized, so 85% return. We're just looking at 6 months, but we're annualizing over the year. That's why we did times 252. This is 64% return, so decent return, right, in 1 year. But again, annualized, so this isn't the guaranteed return, but we're trying to sorry, I've got a bit of a cold. We're trying to standardize this in a format that traders and investment managers and people that work in capital markets can understand. So everything is always annualized, right? We get it into this format, so it's standardized. So INTC is negative 1.1%. Disney is dismal in this case. CIS could be dismal, but don't really know. And Boeing, I think BFA, I always think that's Bank of America. I think it's Boeing, 0.33 negative, right? Let's look at a correlation plot here. This is pretty standard in the investment analysis world, right, to look at correlation. So we can see how well correlated or how non-correlated these stocks are. So in the diagonal, you always see one, right, because Apple is 100% correlated to Apple. Amgen and Apple have a 0.31 correlation. So the darker the color, the higher the correlation. The lighter, the higher the correlation. The darker is negative correlation, right? So some of these are highly negatively correlated, and others are positively correlated, right? Based on the shading or the colors here, right? So 0.88 AXP, I think it's 8 AXP. If I go down here to GS, that's Goldman Sachs. Pretty high correlation for this guy over here, right? So I'm looking at 0.88. So AXP and GS have 0.88 correlation. So that's very interesting. These two stocks should move together over any given point in time. I have other videos I put out about pairs trading and how to make predictions on future stock prices. So this is very relevant to that type of analysis, right? And very useful to see these types of correlations. So I'm going to go ahead and refresh this, Control Enter, and I'll share all the code with everybody, all right, as soon as I post the video. So what are we looking here? What are we looking at here? Network analysis, and we're looking at graph analysis at the same time, right? So I think network analysis is a little bit more relevant. This is more practical. It's more hands-on. It's more feature enriched, and this is how you solve real problems in the real world. Graph analysis is a little bit more mathematical. It's a bit more theoretical. They're similar, but I think in most cases, in the investment analysis world, where we're trying to make real money in the market in real time, we really want to focus on network analysis, right? So that's why we're using this approach right here. When I refresh this, I can see how these items are clustered together, right? So if I move this around, this whole cluster moves together, right? Can move it back and forth. All right, and this cluster is going to move together. If I move this, the others get out of the way. Okay, you have to move because I'm coming through. Look at that. So we can see here the different clusters, right? Amgen is by itself. Walmart is by itself. If I move this, and the cluster has to move a little bit. It's not really cooperating because that's a small guy. This is a big guy, right? So it has to get out of the way. All the other small guys have to get out of the way. So what does this mean when I run this? We can go ahead and visualize the results there, right? And let me do one more so we can see what the actual returns are based on these clusters over here, right? So we have Johnson & Johnson, McDonald's, Coke, Procter & Gamble, and Merck, right? And Merck has negative return, 0.222 and 0.23 volatility. If I go up here, I want to see negative 0.22 and 0.23. So where is that? If I go up to the alpha MRK, negative 22, okay, it's rounding, and 0.22. And let's look at one more. Triple M is 0.85 return, so decent return, 85%. If you put in $100, you'll make $85 at the end of the year, and 37% volatility. So this is 0.85, 0.37. Let's go down here. Where's MK? 0.85, 0.37. Oh, wait, this is it, right? Yep, so it's rounding. So 0.86, it's rounding up, and 0.37. So this is the triple M, right? And this is the cluster for this. So why is this important? If we go down here, we can see the different clusters. We can see cluster number 4 has McDonald's, PGKO, J&J, and MRK, right? So this is cluster 4. All right, so that's cluster 4. This is the largest cluster. This has Honeywell, Caterpillar, Home Depot, IBM, Cisco. If we go down here, we'll see that. Here's Caterpillar, Cisco, Honeywell. Great, and this is cluster 1. So this is the largest cluster. Walmart is all by itself. That's in cluster 11. Walmart is right here. All right, we got 0.64 return, 64% return. If you put in $100, you make $64, and volatility is 0.19. So 64 and 19. If you go up here, we'll see the same thing. 0.64 and 19, right? So everything matches up perfect. It's doing exactly what we told it to do. And then look at the returns, right? So cluster 1 has return of 6%, a little bit positive, not great. Cluster 2 has an average return of 35%, so much better. Cluster 3 is negative 49. I don't want to invest in that. Cluster 3 is what? Disney. If we go up here, Disney, yep, we saw this before. Disney looks dismal. DIS could be short for dismal or for Disney. 0.8. 0.48, you put in $100, you'll lose $48 by the end of the year. Who wants that? Nobody wants that, right? So this is pretty cool. We are getting the best return from Walmart, cluster 11. So if you put your money into cluster 11, pick up Walmart. And just to diversify a little bit, cluster 8 is United Healthcare. So that is good. If I go up here to look at UNH, what's it doing? UNH is 55%. So you put in $100, you make $55 at the end of the year, right? So that is pretty cool. So I'd probably spread my money between Walmart, cluster 8, which is United Healthcare, and let's just pick one more just to be a little bit diversified. Cluster 2, the average return is 35%, and cluster 2 is Amgen. So there you go. You have 3 stocks. You can be diversified and get decent returns if you take the weighted average of this cluster 2, 0.35, 0.86 is cluster 5. That's triple M. Actually, that triple M is a little bit better. I'm looking at this now. Probably triple M. Cluster 8 is United Healthcare, and cluster 11 is Walmart. So if you pick Walmart and United Healthcare and triple M, you'll have diversification, and you're probably going to get about 50% return on your money. Put in $100, you get 50 after 1 year. This is all annualized, right? We standardized it into an annual rate just to make these comparisons easier, right? So in this case, we're looking at network analysis of stocks and graph analysis. The overall emphasis here is on network analysis. It's a little more practical. It's a little bit more rigorous, a little bit more robust. Graph analysis is a little bit more theoretical. It still works, but I think the best approach here is to use network analysis. So again, this code is designed to be very flexible, scalable, up and out. You put in your own tickers here, whatever you want. It can be anything that is covered by Pandas data reader, and they have, I think, around 50,000 different tickers, 50, 60, pretty comprehensive. It's not going to be everything. It's not going to be some weird penny stocks or some weird international stocks, but they do have good coverage, right? So you pop in any tickers that you want, do the analysis. The only thing you'd have to change is the inputs of tickers and the months back. I'm looking at 6 months here. This is somewhat arbitrary. It could be 3, 6, 9, 12. You can go back many years. You can go back 5 years, go back 10 years if you want. Some of these tickers maybe weren't around 10 years ago. But I like 6 months, honestly. Like, that's my personal preference, to go back 6 months. What was happening 10 years ago is not as relevant as what's happening right now today. And I tend to focus more on recent events, not primal events or primacy, right? I tend to focus more on recency. So what's happened in the last 6 months is more interesting to me than what was happening 10 years ago. But of course, you can change this number of months to be whatever you want. So I think that's pretty much it. I think we beat this horse to death. We proved what we wanted to prove, and the analysis was pretty thorough, pretty rigorous, and this did exactly what we wanted to do, right? So hopefully that helps you. This is not investment advice, okay? Just explaining how to do network analysis of stocks and how to understand the overall returns and diversification in your portfolio, right? This is not investment advice, so don't get angry if you pick stocks and you lose some money. That's not my fault. It has nothing to do with me. I'm just explaining the theory and the concept here. That's it. So don't come after me and try to sue me or get angry with me or whatever. Okay, it's nothing like that. But this does illustrate the point of investment management, investment analysis, how capital markets work, and how to pick a return, pick a portfolio based on the returns, and make sure that your portfolio is diversified, right? So you're not concentrated in 1 or 2 stocks. You have at least 3 or more stocks in your portfolio to be diversified, right? Okay, so that's pretty much it. Thank you for your time today. Enjoy the rest of the day ahead. Thank you. Bye.